Hey guys, what's going on? So in this video, we'll be starting off with object-oriented programming, and object-oriented programming is at an intermediate level. Alright, so object-oriented programming is a programming paradigm in which we make use of classes and objects rather than making use of functions and other loosely bound codes. Now, classes are an integral part of object-oriented programming, and by definition, they provide a means of bundling similar data and functions together. Through classes, we can logically group our data and functions in a way that is easy to reuse and easy to extend. And we can access the attributes and methods inside the classes via objects, sometimes called as instances. Now, one thing to note here is that whenever I say attributes, it's actually the data which is associated with the class. And whenever I mention methods, they are actually the functions bound to that specific class. Don't worry if you didn't understand what all I just said now. We'll be looking into this shortly. So let's start with a classic Python example, which is also known as the employee example. So why is it called a classic example? Because whenever beginners start off with object-oriented programming, many software developers tend to teach them with the help of an employee example. So I'll be using that same example over here as well. So suppose you are a developer and you want to track the credentials of the employees in your organization, say name, ID, and the age. How would you do that? Okay, so one way is to create a list for each and every employee and store the credential there. Suppose if I have an employee, say Adam, and you can store his credentials in a list, say his name is Adam and his ID is 123 and his age is 24. Similarly, we have another employee, say Bob, his name is Bob, his ID is 234 and his age is 32, and so on and so forth. Now, you might think this might be a good idea, but actually it's a complete flaw of logic. And I will give you a couple of problems associated with this approach. So suppose there are 2000 employees in your organization. So certainly you would have to write 2000 lines of code, since Python won't allow you to write code on the same line. So if I go ahead and run it, you will see it will throw me an error. That's because you can't type two statements on the same line. So you have to type each statement on each line. So this means if there are 2000 employees, you would have to write 2000 lines of code, and which can actually be problematic since it will make way for larger code files and ugly code base. Now, another problem is that what if some employees are new and they aren't issued with an ID yet? Say suppose Bob is not issued with an ID. All right. Now let's say you want to know Adam's ID. What you can do is you can print the Adam's ID by saying Adam of 1. And for Bob, say suppose you have 3000, 4000 employees, you might not even remember that Bob does not have ID. So if you go ahead and print this, you notice for Adam it is correct 123, and for Bob, instead of it giving us ID, it returned us his age instead. Now this is a really bad tragedy, as I should say, because whenever you are accessing something that does not exist, it should throw us an error instead of fetching us the wrong value. So these are just some of the problems. Who knows what all problems will arise later if we follow this approach. Now to counter this and to make these type of codes more manageable, class is used. Now let's see how class can solve this problem. So in order to do that, we need to create a class. So let's go ahead and create a class. And to create a class, you type class keyword followed by the class name. In our case, let's put it as employee. And I'll be filling out the class details later. So as I told you earlier, whenever you want to fill out any intended block later, you can put a pass and come out. Good. A few things to keep in mind here. So whenever you are typing a class name, it's by convention we use the starting letter of each word as capital letters. So now in my case, I have a single word employee, and you can notice that employee has E as capital. So suppose if I have a variable consisting of two words, say employee India, so I have to put I as capital. So it is just a convention, and it is really good to go with the flow since these are certainly laid out, and when your code is being seen by other programmers, they also get to know that yeah, you are also following the best practices. Okay, so we have successfully created the class, and at this point, let me bring back something that we discussed way earlier. What is class and what is an instance or object of a class? Now, if you remember earlier that I told you through objects we can access class attributes and methods. So that means class will act as blueprints, and for each object we create, those objects would have its own blueprints associated with the class. I know it's kind of hard to get this, so let's create a couple of objects and move on from there. In order to create an object, you write the object name. Let's put the object name as Adam, and then you put the class name, that is employee, and then parentheses. Now with this, you have successfully created the object Adam as an object for employee. And let's create an object called Bob, which also is an object of employee class. So Adam here will have his own blueprint of class employee, and Bob will have his own. Okay, so one important thing to understand here is that all the objects that you create are unique. So if I just go ahead and print Adam and print Bob, and if I run the code, you notice that they both are employee objects, and Adam is located at this memory location and Bob is located at this memory location. And this means that these are two different objects having two different memory locations. So there is no way an object has an influence on another object. Okay, so let me go ahead and clear the screen, and let's add some credentials to the Adam and Bob objects. So there are two ways you can do this. The first one is naive way, and the second one is quite simpler and the appropriate one. So let's start with the naive approach, and let's give Adam's credentials first. In order to do that, you should type object name. So here we have already created an object which is Adam. You type the object name Adam, and you put a dot, and then you type the attribute. So we have an attribute, three attributes, right? We had name, ID, and age. Let's start off with name, and then you give the value as Adam. After that, there was ID, so let's go ahead and add ID as 123, and let's add the age as 24. So similarly, let's add the credential of Bob as well. So Bob, let me go ahead and copy the above code, Control V. Let me go ahead and do a multi-cursor selection, and I will do Bob, and here let me go ahead and change it to Bob, and ID of Bob was 234 and age of Bob was 32. Cool. So with this, we have successfully passed the attributes for the class. Adam has attribute name, ID, and age with values Adam 1, 2, 3, and 24 respectively. Similarly, Bob has its own attributes. Now, if you remember earlier that I told you that you can access attributes of the class by object name, well, let's go ahead and print the Adam's age. So in order to do that, we can type Adam.age. If I go ahead and run it, it gave us 24. Similarly, you can check for Bob's age by typing simply Bob.age, and it will give us 32. Okay, so remember in the earlier example where we use a naive method of using lists to store the credentials? Well, there we actually forgot to give age, I guess. Okay, ID. Remember, we actually forgot ID. And let's say what happens if we don't give ID here at all. Now, for Adam, if you go ahead and Adam.id, if I run it, it will successfully give me the ID 123. And now if I type Bob.id, it will throw me an error saying employee object has no attribute ID. Now in that case, it actually fetched us a wrong value. Now here it threw us an error. That is really good because it actually helps us developers to understand that we haven't assigned an ID yet to Bob. Okay, so this was the naive method. Let me go ahead and comment this out, and let me give Bob his ID back. So 234, and let me actually go ahead and comment these, and let me put it all the way down. Cool. That's because I will be coming back to it again. Okay, so let's discuss the other and the preferred way. So in order to do that, we will make use of a special init method. Now for those who are coming from other programming domains, you might have studied something called as constructor. Well, init is extremely similar to that, and in Python we call them as the initializers. So initializers are used to initialize the state of an object. Okay, so let me go ahead and define that init method. So in order to define the init method, come inside the class, and let me remove that pass since we are now defining something inside class. Okay, so in order to define an init method, type def, then dunder, which is actually double underscore, and type init, and then once again put double underscore. So this method right here is actually called as a dunder method because it's enclosed by two underscores, as you can see here, underscore underscore init underscore underscore, and then put a bracket and type self. Now why self, you may ask? Well, whenever you create a method inside a class, they receive the objects as the first argument automatically. Now by convention, they are called self. You can name it anything you want, say objects or anything. but I would stick to the convention and call it self. And let's pass other arguments of init method as the attribute. So Adam had name, ID, and age. Now come inside the init method, and inside init method you would have to initialize each arguments we passed. This process is called setting up the instance variables. Now we can only initialize the arguments that we passed except self. So to initialize it, you would have to type self dot name equals to name. And one thing to notice that you can pass any variable name as you would like. So I can put, say, first name something, but I like to keep it pretty simple. So I would just type name instead. So similarly, I'll type self.id equals to ID. So this ID comes from the argument, and self.id is created inside the init method, and self.age equals to age. Now the above steps will be much clearer when we create the objects. Let's go ahead and do that. So let me first actually delete the object earlier that we created. Okay, so let's go ahead and create the object for Adam. And one thing to remember, now when we create employee object, say Adam, and we type employee, now inside we need to pass the parameter to the arguments in init method. So by default, Visual Studio Code has given me suggestions. So if you go and look at the init method, we have 3 arguments, name, ID, and age, and you don't need to specify self. And I will tell you the reason why right now. So you only need to specify the parameter value for name, ID, and age. Let's go ahead and do that. So the name was Adam, ID was 123, and age was 24. Let's go ahead and take a look why we did not use self. So if you remember that I told you earlier that whatever methods you define inside a class, you need to put self, and self receives the object as an argument automatically. So you don't need to pass anything over here. So whenever you type self or anything, or the first argument inside any method is always the object which gets passed inside automatically. So in our case, so this self over here, it automatically gets this object value. Okay, so let's go ahead and define the same for Bob. So we type Bob equals to employee, and we give Bob name, ID as 234, and age as 32. Now as soon as we do this, init method runs automatically and maps the parameter values with that of arguments inside the init. Hence Adam object will be passed as self, and Adam string will be passed as name, 123 will be passed as ID, and 24 will be passed as the age. And inside it sets the value something like this. So remember, self got a value of Adam, so it will come here and put Adam.name equals to, similarly, Adam.id equals to 123, and Adam.age equals to 24. Does this look kind of similar? Well, we just implement this in our first way, remember? So if I go ahead and show you that it is exactly the same thing we did. So by implementing this method, we not only reduce the number of lines of code, but we also generalized it. So for Bob, whenever create the object of Bob, here instead of Adam, it gets replaced by Bob. So we have completely generalized and automated the process. Now you can go ahead and access the values as I told you before. So let me go ahead and actually delete this comment. And now you can access the data by passing, okay, let me use print function. Now you can access the data by typing object, let's say Adam dot attribute. So attribute, we already have 3 attributes as it's suggested by Visual Studio Code. And let's go ahead and print the name attribute. So if I run it, you notice it will print me Adam. All right, so I just clear the screen. Okay, so by now we have created classes, objects, initialized object states, and we have accessed the object attributes. Now we are left with one more thing before I end this lesson, and that is methods. So let's go ahead and create a method that will print us the IDs of the objects that we create. So to create a method, go inside the class and type def, then the name of the method. So in our case, the name of the method is, say, display ID, and within the brackets you need to type self. That's because I told you earlier and several times that whatever method we are going to define inside class, we will be making use of self. Now you can make use of any value or any name you want. make sure to remember that the first argument is always referring to the object. So by convention, we make use of self, and I strongly recommend you to follow this as well. And of course, there are some exceptions where certain functions don't take self as the argument, but don't worry about it in this video. I got it covered in some other lecture. Okay, so inside this, let's go ahead and print the ID. Now, one important thing to remember here is that whatever instant variable you mentioned inside the, or you can say initialize inside init method, you can use it inside any method without passing it as an argument. That's why I did not pass the ID as the argument along with self. Now, if you want to execute this function, all you have to do is come down and simply do Adam dot display ID. If I go ahead and run it, you notice that it printed me the ID of Adam. Now, if you want to print the ID of Bob, all you have to do is come over here and replace Adam with Bob. And if I run it, it will print me Bob's ID as well. That's pretty neat, right? Just like ordinary functions, we can expect a return value from display ID. So instead of just printing it, let's actually return the self.id. So let's go ahead and return self.id. And let's come down over here and let's print that return value. So let me cut and paste. Now if I run it, it will still print me this same value. So alright guys, that's all for this video. We really learned a lot about classes and objects. We learned about how to create classes, objects, initialize class, initialize object, how to access the attributes and methods inside the class, dunder init method, self, passing arguments to init method, and so on. At this point, let me tell you that there are lots and lots of concepts inside OOPS, and it's going to get more interesting later as we progress on. So if you really like this video, you can support us, and there are a couple of ways to do that. First and the easiest one is to simply like this video and subscribe the channel. You can also support us by spreading the word to others who really want to learn more about Python and other tech stacks, and it will also help us to grow as a new channel, and we would also be able to help folks like you. Alright guys, see you in the next lecture.